Hi, this module is on survival analysis, and in this video we're going to talk about P's and Q's. You'll see what I mean by that shortly. First, some notation though. When I write a letter X, what I mean by that is that that's just representing an age X. However, when I put parentheses around that X, now I'm talking about actually a person who is age X. So there's a little difference between the X by itself and the parentheses around X. Also, when I'm writing that X, that's my lowercase x. When I'm writing a capital X, my capital X is going to look like that. And I'll say capital X when I write that, or cap X. And generally, that's representing something else later on. So I'm reserving a capital X for something else later on. So when I write lowercase x, I mean lowercase x, and you should write the same symbol. Same with other letters like T's and N's and so forth. Okay. Now, the random variable that we're going to be studying mostly in this class, especially at the beginning, is the time until the death of x. So this cap t sub x is going to equal the random variable representing, that's my shorthand notation for random variable representing the time until the death of a person who is x right now. Now, sometimes maybe we're not talking about a person, but maybe an object, and so you might read this as the random variable representing the time until the failure of the object that's x years old. Okay, generally though, that's what cap t sub x is going to represent. So random variable, we're going to talk about the distribution function and the survival function for the random variable. So the CDF, the cumulative distribution function, the CDF, is generally denoted, the statisticians will write this as a cap f sub t sub x of t. Now what we're going to do is, this is going to get kind of cumbersome right here, so instead of writing the cap t sub x as the subscript, I'm just going to shorten that to just an f sub x of t. It represents, as a probability interpretation, it represents the probability that the random variable cap t sub x is less than or equal to t. And we have a actuarial notation for that, the actuarial notation being a pre-subscript of t, q, and then a post-subscript of an x. I'll read that as a tqx. Okay, so let's look at an example here. Let's look at, say, an nqx. nqx would be the probability that the, so what's happening then, this is, with t being equal to an n, it's the probability that the time until death is before time value n. So this would be the same as saying, the event would be the x-year-old dies before age x plus n. So NQX is representing the probability that an x-year-old dies before age x plus n. I'm going to use timelines quite a bit in this course, and so unlike the timelines in interest theory, the timelines here are going to have two parts to the timeline. There's going to be a time value, and then there's going to be an age. So at time 0, we're talking about an x-year-old. This is my cap t axis, and now I'm going out n years later. I would be talking about an x plus n-year-old. And so the event here that x dies before age x plus n would be the event that x dies in this region right here. And then, of course, the probability of that we're denoting by an NQX. Couple of remarks. Sometimes I write the cap t random variable. I'll forget to write the subscript. That it's associated to an x-year-old, but it's always there. Even when I don't write it, it's always there. Another comment that I'll come back to later on is that I'm using an n right here as the pre-subscript instead of a t. When I'm thinking of this as a probability, I usually use an n right there, or maybe a k, where when I'm thinking of the tqx as a function, then I'll use t as the independent variable. That's going to allow us to avoid some subtleties later on, and that we'll get to. So let's move on. That's what the CDF, the distribution function, would be. Let's look at the survival function now. The survival function is generally the statisticians will write this as an S, and again, they'll write it as a T sub x, but let's shorten that to S sub x of T. And this would be the probability that the random variable cap T sub x, it's a complementary event here, that cap T sub x is greater than T. And our actuarial notation for that is we use a pre-subscript of a t, and then a p, and then a post-subscript of an x. That's where our p's and q's are coming from then. Okay, the timeline for this, if I'm looking at, say, Let's look at say, an NPX. What would an NPX represent here? Well, that would be the probability that, well, before I get to the timeline, let's talk about the event. This is the probability that X survives, X dies after age X plus N, which is the same as saying that X survives to age X plus N, hence the name survival function. Okay, the timeline for this one would look like, so you can see what the timeline is going to look like. These are elementary timelines, but I'm just trying to get you used to seeing it. I'm going to use it often. So this is the cap T axis, and I'm talking about death occurring after time N. Okay, there's a few remarks. There's 3 remarks that I'd like to make here. So let's look at those remarks. Remark 1 is that if you take NPX and you add to that NQX, of course, you're going to get 1. You're taking probabilities of complementary events. The second remark has to do with a notational remark, and that is when you see just a piece of X, for instance, without a pre-subscript, the pre-subscript is understood to be a 1, so this would be a 1px. And then the third remark is more general with these remarks, you know, and it's generally that the pre-subscript is always representing a time value or a duration value. I don't mean duration in terms of like bonds, but just a duration or time, a time value. And the post-subscript is always representing an age. That's the general comment. Okay, so that does it for this video.